For our modern cowbell problem, we are using a Raspberry Pi as the base computing engine. For this is Raspberry Pi 2, which has already been loaded with a micro SD card and has Raspbian on it. We have also put in the Bluetooth USB dongle, which is version 4.0. This is absolutely required because the proximity beacons, they normally use the LE mode of the Bluetooth, and if that is not present in the Bluetooth USB dongle, beacons will not be recognized by the Raspberry Pi. So this is the proximity dongle we are using. It's from Radius Network. It's called Rad Beacon. It's very simple to use. If you open it up, you can open the top part. It has the battery on one side, which is used to power the beacon, and the other side is the circuitry along with the off and on switch, which is used to make the Rad beacon work. To make the beacon work, we need to press the center of this once. You'll see a green flashing light, so this is now on. So first we need to configure this beacon, so for which we will have to press for 4 seconds out here, and we will see that this goes into configuration mode when the green light starts blinking continuously. So now this is gone into configuration mode. The mobile application that is used to configure the beacons are available by the manufacturer of the beacons as downloads from Google Play Store. In our case, Rad Beacon has a Rad Beacon application, and if you press on the desktop icon and put on the Bluetooth, it's absolutely important to connect through the Bluetooth. And then when you scan for the device, now we're going to see the RB bot, the device that we had put into configuration mode. If you see, that's the name for it. Then you have the universal identifier, the number that is given, and then the MAC address for the for this beacon. Now if you want to change anything, just click on it, wait for it to connect, and then we should be able to change a lot of parameters, including which of the beacon specifications we want to use, like iBeacon and alt beacon. And then we can change other parameters, including UUID, major, minor, and measured power. And we can also change the advertisement rate, meaning the speed at which the advertisement is done, and the transmitted power, the power at which the advertising is to be done. Once the configuration is done, we press the apply towards the top of the screen. You have to put in an 8-digit password. Right now we're just using a default of all zeros. Then you apply it, and once the settings are applied, your beacon is ready for use. We can use the Rad Beacon application to measure the range at which the beacons are, just to check. So we press on the settings button, then press range, and then a distance is measured. On the Raspberry Pi, first we need to find out if the Bluetooth USB dongle is working. For this we can use HCI tool. So when we do HCI tool dev and press enter, now we can see the MAC address of the Bluetooth dongle. Now we need to scan for the beacon. For this we can do HCI tool and we do LE scan. Now we should be able to see the RB bot, which is the device that we had configured using our mobile device. We have written a very simple application whose task is to find out all the beacons in its proximity through the scans, and then display the data on the screen, as well as to store the data in a database just to check for later purposes. Instead of showing on the screen, we can just make a sound using the PY game library. So let's see how this works. The call, we have written it as scan person because we've been testing it on person, so we wrote the library as that. This starts the Bluetooth access, and you get a full list of all the devices that are being found by the Bluetooth dongle. All the scan data is stored in this file called scandata.json. It's in JSON format, so we can open it up on a text file, and be able to see the date and time, the beacon ID that was recognized, and this data is kept for all the beacons that are encountered. This is predominantly for debugging purposes, and it allows us to show for how long these beacons were recognized and how many of the beacons advertisement we were able to capture. Uh, all of these applications, especially the scanperson .py file, which is used to work with this modern cowbell tracking system, is available on the GitHub that we have mentioned at the end of this YouTube video, as well as in our Medium text write-up. To test our modern cowbell, we need a guinea pig, and for today Mr. Soilendra is the guinea pig. He's the one carrying the beacon, and he'll be moving around, and then we're going to see on the screen how the data changes as he moves around. Now he's moving away from the device, and we can see that he's getting tracked very slowly. Now as he begins to move further and further away, a point will come when his tracking will completely stop. So now you can see that the beacon that he is carrying is not getting tracked anymore. He's about 20-25 meters away from the Bluetooth dongle. So let's ask Soilendra to come nearby. As he begins to come nearby, now you can see the data coming through. Slowly, as he's nearer and nearer, now it's going to come. Since he is extremely near now it's coming at the speed at which it should be receiving the data. So now we are getting full power. So this is how we can use the tracking method. This video is for a possible solution to the cowbell problem that was posed by Indira from Nepal, which we have tried to provide a simple solution for, and is made available through hackproject.org. We hope that many others will provide innovative solutions that we can study from, as well as we hope that this is a material that will work for Indira as well as for others to have a starting point to study from.